Okay, so I just wanted to go a little bit more into depth about the topics we were covering in Lab 4. So this video is meant to be considered in conjunction with the Lab 4 instructions for precipitation hardening of aluminum alloys, and then the Lab 4 mail-out, as well as the marking scheme in the lab manual as usual. The goal of this lab was to look specifically at the precipitate hardening strengthening mechanism of aluminum alloy. So what I want to do is talk a little bit more explicitly about precipitate hardening and explain everything in depth. And then I want to talk about the two tests we're using, the data that comes out of those tests, and then wrap it all up. So to start off with, the way that I'm going to explain precipitate hardening is using the phase diagrams that you guys have covered in class. So to draw a phase diagram, I want to zoom in a little bit. We need our y-axis to be temperature, and we need our x-axis is going to be composition or alloying. And then we're going to have the different regions of the phase diagram that have different phases present. So what I specifically want to consider is one scenario. So in this scenario, we're going to have an alpha and a beta phase on the lower region of our phase diagram. And then, whoopsie daisies, we are going to have the alpha region on the left-hand side. And there's also some other regions. We have alpha and L, and we have an L up here. But what I really care about is these two when I'm talking about this particular case. So I'm going to imagine that when I am performing precipitate hardening, there's three temperatures that I want to work within. So there's my room temperature, T1. There's going to be an intermediate temperature, T2. And then there's going to be a higher temperature, T3. And so the different stages of the process can be marked by transitions between the different temperatures. So if you look in the lab, we talk about annealing, quenching, and precipitate hardening. So to start off with, I have my untreated samples starting at room temperature. So the first thing I want to do is I want to heat my samples. So at room temperature, T1, there's two phases present. I have alpha and beta. I want to heat from T1 to T3 and hold at T3 for a long enough time that it's sufficient to dissolve the beta phase in my material. So this is going to be my first step. So heat and hold, that's what we know as annealing. So in the preparation of the samples, I did this by taking my untreated samples and I threw them in the oven at around 525 degrees Celsius and held them there for an hour. So the goal of this was to dissolve my beta phase. So the next thing that we do once we've dissolved our beta phase is we want to cool in a very specific way. So what we want to do is we want to cool quickly a quench. So that's when I take my annealed samples and I drop them in water to cool them rapidly down to room temperature. So this is the second stage in my process. That's what's called quenching. And what we're doing when we're doing this is we're actually creating a super saturated solid solution. And from this, we are able to heat our material back up to a temperature below our TS, and this is what causes precipitation of those finer, more dispersed particles that we see in our resultants samples. So that's stage 3, and that's what we actually call precipitate hardening. So if I go back to the beginning and I draw this process out and I look at this process over time, what I'm going to see, so if you imagine a material, we have temperature as our y-axis and then time. So this is what I actually did, and we have our 3 temperatures of interest. We have T1, room temperature, T2, which is within our alpha beta, and T3, which is up in the alpha phase. So I'm going to write it back out again, slightly differently. So first thing we talked about is we go from T1 to T3, so we heat and we hold. So this is what we call annealing. We're doing this to dissolve our beta phase. So this is what we call annealing, our heat and hold, and we're doing this to dissolve the beta phase in our material. The next thing we talked about was that rapid decrease in temperature. So we're going to have almost a vertical line going down. So this is our quench. And that's what we're doing to create our super saturated solid solution. And then we heat back up to our T2, so a little bit of a slower heat up. We hold for some amount of time, and then we allow our material to cool. And this is our precipitate heat treatment. So this is what actually precipitates out those smaller, more dispersed particles at the beta phase. So again, I'm going to mark a few important points and say it all over again just to be clear. So So we're going to look at some specific points here. So time A, we have alpha plus beta. It's going to look something like, let me see if I can draw it. We're going to have some alpha grains, so we'll treat it like this: alpha, 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 and then those spaces in between, we're going to call those beta. So this is our starting point. And maybe I'll just color that in so you guys can see. Beta is all in here and all in here. Okay. So this is where we start. We then heat to dissolve our beta phase. So this puts us at point B, where we have only alpha now, and that's going to look something like this. So we have alpha, 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 alpha. Pretty straightforward. So this is the end of the annealing process. So beta dissolved. Then we quench to get our super saturated solution. So C times C is going to look a lot like B, but it's a solid solution. So if we were to draw our grains, we might draw them like this. So alpha and solid solution. And then when we heat back up, we're going to get those nice, ideally we're going to get those nice dispersed precipitate particles. So I might color these actually. So let's make them yellow again. So let's go. Yeah, there we go. Now we can see them. And so those yellow guys, those little particles that are nice and dispersed, these are our nice little beta precipitates. And so this is retained upon cooling. So we now have our phase diagram drawn out. We have our process drawn out over time, and we can imagine what our structure is going to look like as we move through this process. So hopefully this gives you guys a bit of a better understanding of precipitate hardening.